Alright, let's look at one more type of question. So this one's actually quite different because we're not looking at the locus anymore necessarily, but the question asks for finding the radius and coordinates of the center of the circle. And you may be thinking, oh, isn't that very straightforward? There's always that same format. But the first thing you realize is when you look at this equation, it's not in the same format that you're used to seeing. Right? When we look at the x terms, you can see you've got x squared plus 2x. And if you look at the y terms, you've got y squared minus 6y. But that's not the usual format you're used to seeing, because if you look at this equation over here, for example, x minus 5 all squared plus y minus 3 all squared equals to 4. You know that this is the radius squared. And these values here that make this equal to 0, those are going to be where your center is. But then the problem is when I come back to this equation, it doesn't have that. It's got x squared plus 2x and y squared minus 6y. And it looks like there's a kind of incomplete quadratic almost, because this and this look very different. You're more used to seeing, if we take that form in a general sense, x minus a all squared plus y minus b all squared equals to r, where a and b are the centers. And even if you move that 15 over to the other side, you still wouldn't have that with your variable terms. And just to show you that this is actually a circle, if I've literally just plugged that equation in, and you can see that does create the graph of the circle. But we want to try and find out how can we find its radius and centers. And what we want to think about is, okay, I know that I want to get something that's in the form x minus a all squared plus y minus b all squared. How can I get that? Well, I know that I'm going to have to change this into this somehow, and this into this somehow. And the important thing is we don't want to actually change the equation at all, because then we'd change the actual graph of the circle. So we want to make sure it's the same circle and find its radius and coordinates. So I want to think, do I know a method to go from something that's like an incomplete quadratic to something that's nice? And if you think back to chapter 3, I think it was, we actually did learn a method that taught us that. When we started looking at the quadratic equation, we could solve any quadratic. But the way that the quadratic equation came about, we actually derived that, and it came from something called completing the square. Okay, so if I want to complete the square, all I have to do is I draw a line like this, and boom, done. No, I'm just messy. I'll do a quick example if you've kind of forgotten how that process works. So you can take any quadratic, x squared minus 6x minus 3, and there's two steps you want to take. To complete the square on this, all you have to do is you say, oh, we'll take half the coefficient of the single power. So half the coefficient of whatever the single power is. So that's going to be minus 6 in this case. But then we have to square it and sum to the equation. Okay, so what does that mean? Well, if I take this one here, x squared minus 6x minus 3. Oh, by the way, if you know how to complete the square, you can just skip ahead. But if I take this guy, equals to 0, I want to take half the coefficient of the single power. Now here's the reason why I actually left the constant off in the first place, because actually when you're completing the square, you're only looking at those variables here. So the first thing I'm going to do is actually move the 3 to the other side, and then I want to say, okay, I want to take half the coefficient of the single power. So half the coefficient, half of minus 6, but then with step 2 I want to square it and then sum to the equation. Okay, so I've taken half the coefficient and then I've squared that whole thing. But remember, we want our equation to be balanced. Okay, we want our equation to be balanced, so I'll do one side, yeah, go to the other side. Right? So 3 plus minus 6 over 2 all squared. Now it may seem strange why I'm even doing this in the first place, but you see that this turns out just to be x over minus 6s plus minus 3 all squared equals the same thing over here. And that's just going to simplify to x squared minus 6x plus 9. And over here I'll just get 3 plus 9, which is 12. Now why have I even bothered to add minus 3 squared to both sides? Well, because now I can actually factorize this quadratic in the same sense over here. If I try and think, how can I factorize this? Well, I'll just get x minus 3, x minus 3. That's equal to 12. But this can be simply expressed as something like this, can't it? I can express this as x minus 3 whole squared equals to 12. Now, when you learn completing the square, you learned it so that you could solve quadratics. But then we learned the quadratic formula, which is a much more effective way to do it. And that's because the quadratic formula comes from this. But in a case like this, we're not trying to solve the quadratic equation anymore. I'm trying to rearrange it so it's in this form. And that's something that only completing the square can do. Because when I take, for example, these two quadratics, I want something like this at the end of the day. That's what I want. But I don't have that. So the only way I can try and rearrange it in this form, so I can find the coordinates of the center and the radius, is so that I can, well, the only way I can do it is by using the completing the square method. Okay, so let's start with my quadratics that I have here. X squared plus 2x, y squared minus 6y. Okay, so I want to try and complete the square on both of these. Okay, so for example, again, I'll follow these two steps. Halve the coefficient of single power, and then square it, and sum to the equation. So in this case, I've got x squared plus 2x, and then I want to take half the coefficient of x, which is just 2 over 2, all squared. That's just going to be x squared plus 2x plus 1. How can I factorize this? Well, what multiplies to 1 times 2. Well, those two factors are just 1 and 1. And so we started from something that was kind of incomplete, and we ended up with a nice square, because that's just going to result in x plus 1 all squared. Okay, and same thing over here. I've got y squared minus 6y. I want to take the same process. So half the coefficient, and square it. And I've got y squared minus 6y plus 9. Yeah. And that's just going to be in the factorized form, y minus 3, y minus 3. And then y minus 3 all squared. Easy. Alright, so what do I do next? Where shall I go? So, what was the whole point of that? Remember, I want to find the coordinates of the center of the circle and the radius. So, this is almost there. This is the form that I'm used to seeing. But I'm not quite there yet, because remember at the beginning of the lesson I said, alright, I want to be able to rearrange this equation, but I don't want to change it. And in actuality, when you think about completing the square, you've actually changed the equation. You started from this, but then you ended up with this. So what's the difference? Well, the difference is you've added this term. And if I look at this expression and this expression, the difference is you've added this term. So we need to factor that in to our equation over here. Let me just start off by what we had originally. We started off with x squared plus 6x, 2x, plus y squared minus 6y minus 15 equals to 0. The first thing I want to do, I just want to move the constant over, because that's not a part that we're completing. So I have these two parts here. Now, I want to be able to complete these two components, which I've already done over here. But I want to remember, when I do it on one side, I got to do the other side. So they have to be balanced, right? So if in this case I'm doing x squared plus 2x, and then I'm adding 1, and then over here I've got y squared minus 6y, and I'm adding 9. When I do to one side, I have to do the other side, so I get 15 plus 1 plus 9. Okay? Now, I actually know that this is going to factorize to x plus 1 all squared, so I've already done that part. That's x plus 1 all squared, plus, and that was just 1 minus 3 all squared. And that's just going to equal to 25. So now you know that this is actually the circle with center minus 1, 3, and radius